Now that we mentioned the word inflation, let's talk more about inflation. In general, when we talk about interest rates, we can talk about so-called nominal interest rates and so-called real interest rates. Nominal interest rates is what we've had so far. Same thing as a quoted rate or a stated rate, the rate that's given. What is a real interest rate? It's the rate that's adjusted for inflation. Let me start with a simple example. Let's say you put your money in a bank account that offers a 5% interest per year, right? And so at the end of the year, you'll be 5% richer, right? If you leave your money there for the full year. But let's say something else is going on during this year. Everything you typically buy gets more expensive. Let's say everything is 3% more expensive at the end of the year. So how much richer do you really get with a 5% increase in your money at the bank and 3% higher prices? You probably already figured out that you'll feel only 2% richer because 3% is kind of eaten by inflation. And this is correct. So we say the nominal interest rate is 5% that you earn in your bank. The real interest rate is only 2%. And the difference is the 3% inflation that sort of erodes the value of your money. Now let's look at it a bit more formally, because actually the math I just explained is only approximate. So let's see how we would do it more accurately. Let's start with something simple. You deposit $100 in your bank account. The interest rate that the bank offers to its depositors is 10% per year. We also know that prices are expected to rise over the next year by 3%. That's inflation. The inflation rate is 3%. The question is, what rate of return do you really earn at your bank? In other words, what is the increase in your purchasing power? So how much wealthier do you really get by the end of the year? So let's imagine this timeline with 2 points of time marked on it. This year or right now, and next year, 1 year later. And let's talk about this whole purchasing power concept. What it really means is how much stuff you can buy, so in units. For example, let's say you're buying jeans, and since we're talking about $100 to be put in your bank account, let's say to buy one pair of jeans today, you would need to spend $100. So what is your today's purchasing power in terms of pairs of jeans? You have $100, you divide it by the price to buy a pair of jeans. So 100 divided by 100 gives 1. Your purchasing power the purchasing power of your $100 today is 1 pair of jeans. You can use $100 that you have now to buy 1 pair of jeans, right? And now let's calculate how that would change in 1 year. We're going to use the same steps. Your purchasing money will equal the money you have in your bank account in 1 year divided by the price for a pair of jeans next year. We know that the bank pays you 10% interest, so your money in the bank will increase by 10% compared to today's $100. Right? So we have $100 times 1 plus 10%, just like in chapter 5, a single cash flow, future value. And we divide it by the price for a pair of jeans next year. We were given a 3% inflation rate. So the jeans will cost $100 times 1 plus 3%, which is $103. So now we have 110 divided by 103, and that equals 1.068 pairs of jeans. So today your $100 can buy 1 pair of jeans. Next year, you will be able to buy only a little 1.068 pairs of jeans, a little bit more, which is a good thing. These two circled numbers, so 10% increase in the money in your bank, right? And 6.8% increase in the purchasing power are the two types of interest rate that we are now differentiating on these slides. 10%, like a pure increase in the money you have, right, in the bank, is the nominal interest rate. And you might recall that the word nominal came up when we were covering the topic of effective annual interest rate. So that's how the financial calculator calls the stated rate. It was nominal. And then the increase in the purchasing power, which is 6.8%, right, over 1 year. That reflects how much wealthier you really get, considering the increase in the cost of living. And that's the real interest rate. And if you look at, the numbers that we use to find the real interest rate, you can kind of cancel out the $100, right? They become unimportant. And so what really determines the real rate is the fraction with 1 plus the nominal rate divided by 1 plus the inflation rate. Another thing you can notice is that the difference between the 10% nominal rate and the 6.8% real rate is 3.2%, right? And that's approximately, it's very close to the 3% inflation that was given. So 1 plus the real rate is calculated by taking 1 plus the nominal rate and dividing that by 1 plus expected inflation rate. Using notations, the real rate is lowercase r, the nominal rate is uppercase R, and you can think of it as the nominal rate typically being higher, so it's an uppercase, and you divide by 1 plus h, so h stands for inflation rate. Because there are 3 notations in this formula, there are 3 things you might be asked to solve for, either the real rate, or the nominal rate if the real rate is given, or the inflation rate if both the real and the nominal rates are given. So we can rearrange this formula to solve for lowercase r, uppercase R, or h. This formula here that calculates the nominal interest rate is known as the Fisher effect. So the nominal interest rate, uppercase R, equals 1 plus lowercase r, and then that whole thing is multiplied by 1 plus h, and then we subtract 1. If instead we rearrange the original formula to solve for the real interest rate, or the lowercase r, you would get a fraction with 1 plus r in the numerator, 1 plus h in the denominator, and then you subtract 1. If instead you want to solve for the inflation rate, which is lowercase h, then you also have a fraction with 1 plus capital R nominal rate in the numerator, and in the denominator you have 1 plus lowercase r, or the real interest rate, and then you subtract 1 from the whole thing. These 3 are like the most accurate ways to compute the real rate, the nominal rate, or the inflation rate. The approximate versions are these. For the real rate, you do nominal rate minus inflation. To find the nominal rate, you do real rate plus inflation. And to find the inflation rate, you do nominal rate minus real rate. This will give you approximate answers, which are a little bit off. So in our example, we had a 10% nominal rate, a 3% inflation rate, right? If we are asked to find the real rate, we could do it using the exact Fisher effect or using the approximate Fisher effect. By plugging in 10% and 3% into these formulas, we get 0.068, like we had earlier, and 0.07, right? So this is the approximate real interest rate.